Okay, this is section 9.2, problem 5. I'm here focusing more about how to use a calculator to solve this problem. So I'm going to use this example here, view an example, and that will help me, to follow the steps. All these things you need to know, keep continue, and wherever you need, like for example, the first one you have to choose a null hypothesis and alternate hypothesis. In this case, you can see that there are two averages we have given mu1 and mu2, uh, and then average x bar, and for two different things, and then standard deviation for two different things like no candy and two candies. So we are trying to check, our null hypothesis would be, it doesn't matter either you give the candy or no candy. So mu1 equal mu2, and then um, if you give the candy, then that will change. So that means the alternate hypothesis is mu1 is less than mu2. Here if you just read this everything, it will tell you, the information more detail. Okay, so original claim is, if original claim is false, then mu1 is greater or equal to mu2. But our alternating hypothesis would be just opposite of this, which is mu1 is less than mu2. Okay, so keep continue. This is the formula you have to use for finding the t value. If you don't use calculator and use the formula, you can do that, but I'm going to show you how to use calculator for this problem, which gives you the t value negative 4.08. So first of all, go to your TI-8384 calculator and go to test. Where is that? A stat, and then test, and what is that? What did I do? Test, and then there is a two sample uh, you know test here. There are two samples. That's why you have to go to two sample t-test, and then from here you choose. You just put the value for the stats for these two samples. For the first sample, the average is 18.95. So I'm going to, uh, just 18.95, so that's supposed to be 18.95, and the standard deviation is 1.5. Here I have 1.37, so I'm going to correct that. And for the second one, and then size is 20. That's the value of uh, size. That's a 20. So I'm going to replace this by 20. That's for the first one. For the second one, the average is 21.62, 21.62, and the standard deviation is 2.51, and then sample size is, again, it's a 20. And then if you go down, you'll see the situation where mu1 is less than mu2. So mu1 is less than mu2 is second one. Enter and go down, and then just choose no for the pooled, because it's not pooled one, and just calculate. And if you do that, it will give you the t value. Look at here, t is negative 4.083576. That's the t value, and p value is 1.44. So if you continue here, your p value would be 0.00. If you focus here very closely, you can see that there is a e to the power negative 4. E to the power negative 4 means you have to just divide this number by 10000, or you just have to keep this number 4 decimal places to the right. If you do that, it will be 0.00014447. So that means if you round it to the 3 decimal place, that means the p-value would be 0. Okay, so focus on here, e to the power, what is the power? If it's negative something, then you have to shift this number that many place to the left, to the right. Okay, so that will give you the p-value 0. So now, because our p-value is 0, we are trying to find out what is that, in this case. So we found the p-value, and now the significance level here is less than alpha. What is the alpha? What is the alpha here? If you read the question, An experiment was conducted, and yes, use a significance level 0.05, and since the p-value is 0, which is less than 0.05, so for the p-value method, reject the null hypothesis because the p-value is less than alpha, and fail to reject null hypothesis if p-value is greater than alpha. But in this case, because p-value is less than alpha, so we need to reject the null hypothesis. So then restate the decision in simple non-technical terms. So these are the options. Now to answer the second part, where you have to find out this confidence interval, this is the formula you have to use for finding the confidence interval. You have to find the margin error by using this formula, and that will give you the confidence interval. If you want to use the, that takes a lot of time. That's why you have to use the calculator. So I'm going to show you how to use a calculator TI-83 or 84 for finding this confidence interval. So this is the two sample. So for finding the confidence interval, go to the stat test, and if it's just one sample, then you can go to number 8, which is t interval. That will give you the confidence interval, but it's a two sample, so that's why you have to go down a little bit. It gives you the two sample t interval, number 10. So enter that and put your stats, where x1 is 18.95, which we already use that value. Standard deviation is 1.5. We already use that one, so it's already stored here in our calculator. And if we go down here, the confidence level, you need to calculate. A confidence level can be calculated by 1 minus 2 times, because it's a two-tailed test, 1 minus 2 times the significance level, which is 2 times 0.05. So if you do that, 1 minus 2 times this gives you 0.9, which is 90% confidence interval. Okay, so if you are just taking the one tail test, then that means the confidence level would be 0.95, but because it's a two tail test here, so not equal test, that's why it should be 1 minus 2 times significance level. So in this case, the significance level would be confidence level would be 0.9, which is 90%. And now again, pulled no and calculate. That will give you the confidence interval. Yes, so this is the first one is your confidence interval, which is negative 3.78 comma negative 1.56. And if you continue this, that's what you're going to get. The confidence level is 90%, and the confidence interval is negative 3.78 and negative 1.56. That's what we found here, negative 3.78 if you round it to the two decimal place, and negative 1.56. Okay, so that's how you find the confidence interval. Now depending on the value of this interval, if it's negative or positive, you have different conclusion you can make, and you can read it. If the confidence interval is contains 0, then difference is not significantly large. If the confidence interval contains only positive value, then the difference is significant and positive, which indicate that mu1 is greater than mu2. But if the confidence interval here only contains negative, then mu1 is less than mu2. Okay, use the information to interpret the confidence interval, and depending on what you have got. In this case, it's a negative, so mu1 is less than mu2. Okay, so that's how you can solve this problem using the TI-83-84 calculator.